Let us move on this process quality test, which is inline process. When you are taken to the productions, what are the tests which you have to mandatory to done at your premises. Though EN satisfies these tests, so not only for making a test, so this will help for a successful production. Will have a less quality rejections. So if you start doing this process quality test, so it will enable us in lot. Let us see the molecular sieve test, what it is. So this is you take a glass of water, like with 100 ml of the water on a beaker, and you measure this water temperature, how much it is, and you can note it, probably the room temperature or less than that, you can note it, and you weigh 100 grams of molecular sieve, okay, and take out the weightage and measure this molecular sieve. You put in a beaker, you can measure the molecular sieve temperature. If it is more than within a second, like for example, if it is if you the moment you enter, if you moment you insert this thermometer, you will have within a 2 to 3 second, you will have a 60 degrees centigrade, it will be shown. So after you note down the point of your this molecular sieve temperature, then you will have to pour it on the, you have to transfer this molecular sieve one beaker to another beaker, which the water contained beaker, you have to pour it on the water contained. Then you will have to test immediately with help of thermometer. Okay. So the moment, so this is the calculation I will tell you. So water temperature and molecular temperature. So both you have to add the temperature. The delta T, the temperature, if qualifies, if more than 32 degrees centigrade, the molecular sieve is fit for using your IGU. If it is not, delta T is 32, less than 32, please do not use it. So this is the test will conduct, because you will have to do it every time. So if you are not doing the properly, or if it is water absorbed hydrocarbons or pre-nitrogen, so you will not have this value, you will not be able to get the value. So every time please ensure you will have to test molecular sieve test. Okay. And this two-part sealant mixing test. So I will differentiate here. You can see this, the first picture, pour mixing of 2-part silicone. You can see that black and white, it is not, the homogeneity is not proper, whereas you can see the bottom one, the good mixing of 2-part silicone, so which is completely black. Okay, nowhere it be traces. So if you ensure, how you can do this test, basically you take a small piece of the glass and put your secondary silicone on this, and take out one more pieces and squeeze it with your hand. Okay, and you can see that the impression which comes from the glass, you can see that. After then you can do an addition test also. For example, if you can keep it here, after a couple of hours, like for example after 8 hours or 10 hours, if you try to remove it, if you are not able to remove it, the addition is proper. So even not only the mixing ratio you can test it here, you can addition test also, you can do it here. And next is commonly people are using its butterfly test. Basically you take a piece of paper like A4 sheet, the stiff paper, and you apply the silicone on the one side of the paper and fold it and just remove it gently, and you see is there any split, which means is there any air pocket, or is there any bubbles, or is there any color difference like black and white. Then you can understand, you can see there is third picture, you can see there is a white, because it should be all around black color. If you have a chance to see if any whiteness is there, then which your mixing is not proper. The fourth picture, you can see the below one which I indicated through, it is completely black. So which means your butterfly test, which is qualifies their test. Next is snap test will go on. This is you take a beaker, put your silicone, like for example like a small amount of secondary silicone when your mixing is done, then put a, like either you take any metal or aluminum spacer or glass piece, like in such a way you can dip it inside the beaker, you can do it, try it. So, stick inserted on the cup with the silicone. This is the first step. So, next is before snapping, which means every few minutes, you try to remove it, very gently. Okay, up to 30 minutes you can do this test. So, the moment which peel off, which is the snap it, which is from the silicone to the stick, which is apart each other, that moment you have to note it down, that is called a snap time. So, with that will be a within every minutes you have to do it. Okay, every for example 30 minutes you take it, from this 0 minute to 30 minutes, every few minutes you have to conduct this, slowly you have to drag it, do not do it like fast, like pull gently, then you will understand the snap test. So, if it is not snap, if it is not cut, then you will have a problem. If it is comes like kind of gel, it's still your silicone is still on the stick, then it will be a problem for your silicone mixing, and which is not cohesively, it is adhere. And let us see the peel adhesion test. So, which means you take any metal or glass surfaces, you apply the silicone, and one face where that silicone which is contacting on the face, you can apply any double set tape or bond breaker tape, or any surface like plastic foil. Better you can use a double set tape, so that it will be helpful for to remove that also. So, those areas you apply the silicone in a uniform manner on a glass surface or aluminum surfaces. You can see the next second picture, you try to remove it. If you are able to remove it, like for example gently you just try to remove it. If you are able to remove it, which means it is a peel adhesion test, adhesion failure is there, it is not completely adhesive in nature, it is not compactability is failure is here, which you are able to remove. Whereas, you could, the first picture shows here, that is a right, which is a cohesive failure, which you are not able to take out the silicone from the surface, either it is a glass or aluminum channel, which means your peel adhesion test is satisfied as this one. And this is the shore hardness test, which will use like 100 by 100 aluminum channel, where you fill the secondary silicone. You can use this shore hardness test, you can keep after curing it, you just use this instrument to test it. So, after 24 hours of curing, you check the hardness. So, the shore hardness, if it is okay, the silicone shore hardness would be 35 to 50 shore A. If it is it's satisfied more than 32 or 35, which means your mixing is proper, your secondary silicone it's mixed properly, we can very well use it. Let us see what are the companies have been producing the silicones. So, Dow Corning, TrueSeal, PRC, GE Silicone, Wackus, Bostik, United Polymer Lab Limited. So, these are the companies widely supplied all over the world as well as India. So, you can see this, and let us see the edge deletion. This is the most important process of IGU. Whenever you do the Louis glass usages, this is not required for the clear glass double glaze unit. This is only for Louis glass usage, because the Louis glass has a silver in nature that will react with the coating, and you will have a goldenish finished. So, that is why in order to avoid that goldenish finish, and the silver should not get in the oxidized. Basically, if it is contact with the air, it will get oxidized. To prevent that one, so we will have to remove from the coating from the glass. So, this is the picture you can see here, with at the time of cutting or after tempering also you can do it here, or manually also you can do it also. So, only the periphery of the edges we have to remove this, the nano coating of metal oxide coating has to be removed. So, these wheels are resin bonded alumina wheel has to be used. So, it will be gentle, so that way it will not create scratches on your surface of the glass. So, the function of edge deletion only to remove those edges, the periphery edges of coating. So, not to adhesion, it will promote your adhesions and it prevent oxidization, and these are the facilities. And let us look at it visual distortion. We have a local distortion, which is a roller wave and overall bow resulting from the heat treatment process. Basically, tempering process will have an effect of a roller wave. See, at the time of tempering, you will have a zebra board. You can see here. So, first picture and second and third picture, you will have see. So, as long as you can able to see that the zebra line and as a uniform in a straight line, your tempering process is okay. It can be ready to use as a glazing. If it is not there, then the same effect will be seen on your glazing. When the facade system, when you glaze it with the same glass which has a distortion, then you are forced to see that distortion would affect on your after glazing it on your facade. And this is how your facade is going to be look at it. So, we have to be very careful in terms of roller wave, which basically the heat treatment process. So, that it can be controlled, it cannot be eliminated. This can be controlled with help of heat treatment process called a tempering process. And glazing constraint, there are sometimes the glazing constraints are there. That's the glazing, if it is not properly used silicone, or if any bolt nuts which is piercing it, or it's contacting on the glass surfaces, one edge will be tightness than the rated capacity tightness. So, your structure also will give a glass deflection. So, that will also go into effect, and it will affect as a distortion effect. And visual distortions like deflection by climatic condition, not only the process, also the climatic changes also, like variation in atmospheric temperatures, high altitudes will play a major role. For example, when you produce here, when you send it to like a higher, like more than 2000 sea level, if you go and glaze it, so there will be a different altitude together when you glaze it on the sea level. So, we will have to keep in mind, we will have to figure out. So, you can see the here, this is our normal glazing. If it is winter, the glass will go into bulging effect at the inside. If it is summer, it will be bulging out towards white. So, because of the convection air getting heated up inside, so thereby the bulging out. The air, winter side will suck the air, so that is why it goes inside. So, you can see the next picture, the bend, whichever way, concave and convex way. So, whichever way the deflection goes on, either way you will be able to see the distortion. So, we will have to be carefully select the altitude pressure. Basically, the altitude we cannot select, but we can have a pressure equalizer at the time of glazing or dispatching itself. And failures, poor spacer corners, space joint constructions, failure of structural seal due to aging, incompatibility of glazing material if you use it, and extreme environmental conditions, poor quality control, like window washing, like cleaning product that may affect chemically and incompatible with the silicone materials. So, these are the common DG failure will cause effect. Let us move on to the troubleshooting. Like having said that, we have discussed the pre-processing most important. So, check the water quality, check the conductivity, like it should be the 0 to 10 microsiemens, pH should be 6 to 8 micros pH, and salt content of the water should be less, it should not be acidic or should not be alkaline, it should be the neutral. That is why we have been discussing about it should be pH in the range of 6 to 8. And due to the dirtness, so your roller, your machine has to be maintained properly, so thoroughly have to be keep it. In case you find any substance or any stains on your rollers, you try to use on the acetone, so you can thereby you can eliminate those stain marks on the glass. And this is an IGU with the condensation effect. So, this effect which widely we discuss about, this will have because of your desiccant which failed. Basically, it absorbed pre-absorbed nitrogen or hydrocarbons, water, it's enormous water has been absorbed. So, it cannot perform because it is already absorbed 100%. So, it will not be performable. So, that is why the IGU you will get failed. So, you will have an effect of condensation, which means foggy effect, you will not able to see through inside outside. So, you will have to replace your DGU. Next reason is like desiccant absence in spacer, it is complete failure. Desiccant absent in the spacer, desiccant should be provided in the aluminum spacer. So, we will have to keep in mind, if you are not able to use a desiccant, or if you send without the desiccant, it will be a problem. And secondary silicone is absent in patches, like apply thoroughly, uniformly, continuous manner. There should not be any discontinuous manner. So these are them. And proper sealing, not after organ gas filling. Sealing has to be done properly, which we discussed almost. No, dirtness should be there in your machines, but you have to avoid. So you should not live with that. You will have to come out with a solution called how we can protect this from no, dust, water, washing quality, this thing. So this will be a maintenance process, and at the time of production you have to keep in mind, we will have to thorough visual quality checks and each and every process, because it will help us in the long run. And IG with the scratches. So this is a major due to your brush, which is has a high abrasive, because it is served a lot. Maybe your micron will be less and your become hard brush. At the time of washing, people should not use hard brush, but be used mild brush, or glass stacking, splinters, any form of scratches can be created in a many form in a processing. So we'll have to carefully do it at the time of processing. So sagging effect, which we discuss about, the more panel, the size of the panel, length and width is more size. So the gravity force of glass, it tends to go down. So not to avoid that one, you have to use argon gap or any performance gases. So that way it will be dry air also it can be used. So there will be the sagging effect would not be there. And moreover, if you use as a vertical glazing instead of doing on a horizontal glazing, vertical glazing will not have a sagging effect if you use a robotic machine rather than doing a manual process. So this is a troubleshooting. And let us move on. That is the final slide of my presentation. This is handling and storage of IGU. So handling and storage is it's a part of processing, not only the production. Once you are done, the curing is cleaning is over, you should not away from that practice. So handling is most important, because you have done a proper job so far from cutting, grinding, washing, tempering, IG process that's cured now ready for the dispatch, because the customer wants to receive this your finished product. So that handling should be a proper. Basically you have to separate with the separators and use like wherever you need a paper, or if you need an interleaving powder, you have to use it, and ensure transportation and storage of both panels are equally supported. It should not stack in a zigzag way, should be in a 6 to 7 degree at the angle of you have to stack it. Do not stack it on horizontally and transport it. Should be in a A-frame, should be in a 6 to 7 degree. So such a way you have to do it. And insulating glass unit, suitable interleaving should be used, and all insulating glass unit must be stored in dry and ventilation conditions. It should not exposed to the sun or the heavy rainfall. So because your customer going to receive, if it is a rainfall or any this thing during this one place to another place, the transportation, the water substance will dry and it will accumulate the dust from the atmospheric. It will have a different effect altogether. Again, people wants to clean at the surface. Again, when the time of cleaning, the people who tends to create the scratches. So we have to be very careful at the time of dispatching also to protect the tarpaulin or prevent from abnormalities, whether stacking or transporting. Please keep in mind that one. And if it is necessary to rotate large panels of IG unit, you can use the corner blocks, like where you can use a corner block, you can be ready-madely made. It can be used at the time of bigger DG when you lift it. We can use it as a corner block, so it will not break. Again, the vacuum lifter, like you can use manual lifting is not possible, then you can use a automatic vacuum lifter. It can help us in the long run. So with that, I'm finishing with my presentation. Thanks for learning. Happy learning.